yellow class. Today is Thursday, February 9. I'm going to take a look at standards 2 and 3 and test on those. We're looking at page 61, I believe. Alright, so let's eat this up piece by piece. I'll need people out there to help me with the calculator because the numbers are a little bit bigger. Nonetheless, and we'll also try to answer the extra questions justified, just in case some of you who did it, and a few people did the actual problem, but they didn't do the second version where you say, oh, what does it actually mean in the actual problem? So I'm going to give a lot of information. Most of us, you just need 3 out of 4. There are 4 things they're going to ask you to do. If you get 3 out of 4, you win in this section. And the reason I say that is, again, some people, either A, who don't like math, or B, have a hard time in math. If they know, like, wait, all I need is 3 out of 4, then it kind of helps them get in. All right, let me get my 3. I'm going to do the 3 easiest parts first. That fourth part where you get the maxima, needs a little bit expanded, but let's see what we can do. All right, here we go. We are going to be factoring this. This thing called complete the square. We're not going to do that. In the world of math, complete the square is it's an extra long process, which at some point in your life you might need to know, but not from me. I'm going to go straight forward with the factoring. Step 1, to factor a quadratic. That is called a quadratic because of the little baby 2. Quadratic. It's also called a trinomial, okay, because it has 3 terms, 3 pieces separated by a plus or minus sign. Is it called anything else? Yes, it is also called a polynomial. I don't know if I wrote it somewhere else, but I'll write the 3 names of things that it can be called. Why do I get the names? Can we just do the math work? The idea is, some math teachers are going to say, all right, today class will be factoring the quadratic. What is that? Whereas at least if you've heard, oh, it has a little 2, he gets to call it a quadratic. So what are the 3 names? Quadratic slash polynomial slash 3. There was a third thing I called it, and I don't remember right now. Quadratic, polynomial, trinomial, and actually there's a fourth one, because I have 3 terms, trinomial. Trinomial is a special name of a poly just means many, polyphonic, poly something else. That's a lot. And really the other one I could have written was something else, polynomial, trinomial. I'm going to put parabola. Now that one you know, but we don't call it that. How do we know it's a parabola? I wonder where they're writing it. I'm squeezing in here. I wonder where you guys are writing it. Parabola. Hey, how does he know it's a parabola? Again, that little 2, even though it has all this extra stuff, can anyone say what happened if this was a parabola? Because there's a plus 300 at the end. With the picture, what really happened to the picture? Because that plus 300. It was moved up 300. If this was a minus, you know how it's just me saying you don't have to do anything. You don't have to write this part. Just commenting, kind of connecting the original. If this were a parabola, because the little 2, the plus 300 moves it up. If it was a minus 300, move it down. You have to write that part. Just comment on that from unit 1. All right, let's do this thing here. All right, step 1. We got to get rid of that outside 5, just like on the problem next door to it. We got rid of that. I think it was a negative 3. By the way, if this were happen to be like a positive 5, you still do the same thing. Divide 5, 5, 5, under all of them. So this first step, I expect to see on your page is somebody, I think, on the old version, maybe more than one person, they do this divide 5 thing. Here's what they wrote, like if they were doing this problem, they did. I'm going to erase this part, don't write this, don't write this. What are 2 numbers that if you multiply them would give you 300, but if you added those same 2 numbers, you get an 85. The way you should know, like, whoa, I did something wrong. If the numbers are big like this, they won't give that to you. Because who knows what you multiply to get 300. I mean, and then adds up to 85. It's just too big. The numbers have to be smaller somehow. And even though this particular problem that we're doing, the number's going to be bigger than the original, we'll have 2 examples. All right, let's see what we got here. Someone help me. I know when we divide 5 into 5, we get a 1. Let's see if I can just put that there. When we did divide 5 into 85, I need a little help there, and because the signs are different, I know it's going to be negative. If you didn't know, on your calculator, when you punch it in, you hit positive 85 divided by negative 5. What does it give us, anybody? I hear negative 17. I'm nervous about that 17. That's sort of like a big number. Hopefully that doesn't hurt us. And then someone different, that positive 300 and, divided by that negative 5. I hear negative 60. Of course, make sure someone else does validate the case. Okay. We got that confirmed. Now here's the deal. This line here is what we're going to be using. But you have to know so that when you finish off the problem, for those who do that fourth step where you get the maxima or the vertex, technically we just factored out a negative 5. And that's math talk. I hope one day you can feel that factored out, or if you factor something, just means if you're given an original problem, can you rewrite it as a multiplication problem? That's what factor means. Can I write this long thing as something times something else? Yeah, I can. A negative 5 times all of this would give me the original. So when you hear factor, things factored, I just want you to feel like, even if you don't know how to do it, like, oh, you want me to write it as a multiplication problem? That's good. I don't know how. I know what you're asking me to do. All right. I was going to say the black guys, but I don't want to say it that way. We're going to factor them, what's inside of here. This part, some people mess up on a little bit too. Not just in this class, in the past. The 60 has to go somewhere, the 17 has to go somewhere. The last number goes on top. Somebody put it on the bottom and they just couldn't figure it out. So I'll put a negative 60 on the top. I wish I had a highlighter to make it one color so it stands out. As a matter of fact, if you can grab a highlighter, do this please, even if you're super good at it. Grab a highlighter and just highlight the negative 60 and just highlight it that it's on the top. I want that part just to stand out. And the idea behind it, hey, I typically don't have highlighters. The idea behind the highlighting is once the 60 is in the right place, there's no other place but to put the 17. All right. I'm not used to all the time on this because, again, where are you? 17. 17 is on the bottom. The question we must ask ourselves is, what are two numbers that when we multiply them, that gives us 60? See what I'm saying? The numbers are big, but when you add the same two numbers, it equals 17. Do this for a second on your own. Have I not been recording at all? Surprise! Whatever you're watching, they're like, whoa, where all that come from? All right. What are those two numbers? Anyone? Oh yeah. 20 and 3. What I was going to say, the numbers have to be 17 apart. But for someone who's not that good with this, thinking of two numbers that are 17 apart, like that's going to be the thing that makes you go like, oh, 17 apart? That's the part I was missing. No. So 20 times, 20 times 3 is 60. If you get lucky enough to get the two right numbers, the sign, there is a little part there that helps, and that is the larger number always has to have the same exact sign as the number on the bottom. So because the top one is negative, yes, the sign's going to have to be different. I don't know which one's going to have which because I'm not good with that, and subtract positive negative numbers. This one you luck out on because whatever the sign is on the bottom, it has to go with a large number. Because he's negative on the bottom, his friend here has to be negative also. A lot of work. Again, after all that, we haven't even gotten 1 out of the 3. I think one person, maybe near the past, they got this first part wrong. In other words, here comes the factoring part. You know you factored it, you know you have two parentheses next door to each other. Some students just leave this and they're like, all right, I did it. No, you didn't do it yet. Because in order to be factored, you have to have a multiplication problem. This big thing times this big thing. And what goes inside the big thing, of course, is the minus 20, and then your plus 3. Again, for those who don't need it, you got it right last time. You can just ride along with us. Pause. Any question where I got the minus 20 or the 3? Take it out of the big X, the magic X, that's what people call it. One other thing that some people make a mistake on, sometimes they'll change the signs on it on the factoring level. Factoring is just to get the guys inside the parentheses. To get your zeros, I'm going to write it right below it, and then I'll put the answer down here. Can someone tell me what the first zero is going to be for the 20? 20, comma 0. It's always the same number, opposite sign. The zeros are just asking you the question, hey, what number do I have to put in place x if I want to turn this parenthesis into 0? Oh, 20 minus 20, oh, that's 0. That's why it's always the same number. And then it has to be opposite sign. When you add opposite signs, of course, they cancel out. Hey, someone else, please tell me what the 0 will be for the x plus 3. I'll take it, thank you. Now notice how I'm writing it right below and then adding on the 0. Technically the answer goes here, but sometimes when you pull it apart, some student thinks it's something different, something more. So I'm going to rewrite it. This part I found was a little tricky for some people because we're about to go from this. By the way, so far I got 2 points. So if I can get the first point, automatically I get 2. After that, for those who need just the bare minimum, the fastest part, you need just one last part. And your calculator will do it for you. I have what I call zeros. These zeros, if we were graphing this, and you don't have to graph it, just so you can feel why they're called zeros. This is a parabola. It was a negative, so it's going to be pointing down. I'm glad I can say stuff like that to you now that you forgot before. It just says that at 20 and at negative 3, the parabola hits the x-axis. If this were the ground, it hits the ground at ground 0, at 20, 0, and negative 3, 0. That's kind of what it means. Do you need to know what it means? No, you're 20. You're fine. Here comes that last one. Now, they wrote them out of order. Should I skip all the way down to mess it up, or should I just do the next one in line? Why didn't put the line of symmetry next, so I can just kind of do the next line and then get the maxima next? I don't know. So skip all the way down. Now here's what I'm going to do. I'm going to reverse. I'm going to take the chance of confusing somebody. Like, what does the arrow mean? It means I'm going to get the line of symmetry first, and then I'll get the maxima next. Line of symmetry. Anyone remember what you do to get the line of symmetry? It has to do with that 20 and that negative 3. You will be dividing something, yes, but you got to do something before you divide. Anybody want to help her? Right. I hear bring it down. That's going to be important. And then do what with the bring it down? I heard the adding. Very nice. So here's the deal. So I'm going to put this. I'm going to put a plus sign right there. The guy in front gets to still go in front. The guy behind gets to still go behind. You know how easy that is. I want half of you in here to remember this comment that I'm going to make, and that is, especially if you ever felt like you're not that good at math. Really, math is a lot. It really is. Like, some people, yeah, they're good at math. I don't know. If I remember all these steps, I do each one along the way, and then I get the right answer. If I forget any of the steps, I miss the answer, and then I miss the problem. I just want you to feel, if ever you felt like, okay, if I can get better at math, go online, look up how to memorize things. The best way to memorize things is always over 2, always over 2. Improve your memory, improve math. Now, it still stings a little bit, because when I'm working with my son, he doesn't even want to do the formula. But, oh, come on, let's do it. I'll help you. Sometimes I even ask him to use the calculator. That way he feels like he's getting over 20 and a 3. Yeah. Thank you. And then let's divide it by that same 2. Calculators, I know there's going to be a decimal. 8.5. Take a look at it. This line of symmetry has to be written as the letter x. That is, x equals 8.5. So,
where'd you get the 2?
That is part of the thing that I just say to you. In other words, to find the line of symmetry, which is halfway between these 2 dots, and I already erased it, you have to add them and divide by 2. So the divide by 2 part is the part where the teacher says, all right, in order to get this one, make sure you divide by 2. So you shouldn't have known it just like out of the blue. Good question. And so again, if I were writing this thing, kind of made it go like that. The line of symmetry, here's my negative 3. Where was that? The negative 3 and my 20. Your line of symmetry is saying, what's halfway in between? Like, what's going to cut that thing right in half? And we found out that it's 8.5. So right here at 8.5 on the x-axis is the line that cuts that parabola in half. The last question they're going to ask you is, hey, what is the vertex? What's the top point of this parabola? So the top point of this parabola is wherever I found this x equals that, I go back to the original equation. By the way, at this point, anyone who wants to stop this, you can. You've got your 2 points. For those who want to get that third one, all you have to do is write down the original thing, which I think we had a, what are you? You are a 5, a negative 5x, I'm not going to memorize it. 5, 85, 30, 5, 85, 30, 5, 85, I don't remember the sign of it, and 300. You get an x, plus or minus 30, anybody know? And then plus or minus 85. Oh shoot, let me get rid of this x. After we get these in, for those people who are getting the B section, I'm going to say what each one of these things means. And then that way you not only get the points, but you can go to the next level. Hey, to get the maxima, that's what I'm doing right down here. All of this down here. The maxima is sometimes I'll put here. Maxima, I'm also going to put vertex, maxima. Again, for anybody who's like, okay, I'm out of gas on this one already, you can't stop. Getting those 3 are fine. This thing down here, to get the y that goes along with this x. Because again, this final answer is going to be something, comma, something else. It's going to be that 8.5, comma, some number. The vertex up here is going to be 8.5. There's the x, comma, whatever the y is. 8.5 wherever you see a parenthesis. 8.5 wherever you see a parenthesis. And for those who are like, okay, how do you know if a parenthesis there? In the original problem, there were x's after that negative 5. So then square mine. And there was an x after the 85. Well, we're going to replace the x's with that 8.5. And that will give us whatever this is going to wind up being. I'll ask someone. Oh, this one I want actually everyone to punch it in. Normally I would have asked you to punch it in. Make sure you're not on the y equals button. You're on the blue button mode, just a regular calculator. So that when you punch in all of this stuff, now this one I do want to see everybody's, because if you can't punch it in the calculator properly, even with that tool, it won't give it to you. We'll find out with the partners. I don't know what the partner is right now. What was a 661 point something? All right, so let's say something about this now. Because again, that last piece, even though I did want to make sure everyone got it, I'd say if you don't forget that. Then again, it's still okay, because again, if you read box 2 on the assessment, you should always read box 2. I think it'll say you need 3 out of 4, and that was the 4th. All right, for those who go on to the part B, let's talk about what it actually means. Let's see. In order to say what it actually means, you have to read whatever they were. It was in the little paragraph. So let's see what this was about. Just can throw a football at the speed of 85 feet per second. The function to model the height. Model is, if you could double underline the word model, just so that when Matthew starts throwing it around, it seemed like we just started throwing it around recently, but to model something means something's happening in real life. Hey, can you write down like an equation that kind of would produce a picture that looks like that thing? You model this situation because this parabola is going to travel the way the football would travel. Here it comes. The height at the time x of throwing is h, and then they give you the whole formula. Here we go. Question number 1. Why you chose this method? For this one, you could say it's the easier method, even though that question isn't as important as the others. Why did you choose a factor instead of including the square? That assumes that your teacher taught you. For now, you can just put it was the easier method, or you don't even have to answer that first. Here comes the second. Solve for the zeros and explain what they mean within the context of this problem. Here are the 2 zeros, the little pictures. Hopefully, you can see it. Technically, the zeros are where the football hits the ground. If it's a missile, it's usually where the missile would hit the ground. These trajectory things are always something is going into the air, and your zeros are when is it going to hit the ground. Now, this negative one technically doesn't mean something as if so you throw the ball that way. If you were to throw it backwards towards the ground, it's kind of a weird thing. So technically, a negative 0 has no meaning in this context. It doesn't mean anything because the zeros here have something to do with time. In any case, is the amount of time it takes for the football to hit the ground. I guess I should write that up there. Again, do you need this? If you're like whoa, it's too much help. No, you don't. Relax. Let somebody else write it down, or you just let it go in your head. Don't bother with it. But here the zeros. It's when the football hits ground, the time. When football hits the ground. The clock. Because of the time when football hits the ground, there's no negative time. What's the next thing they're asking? I'm going to go to the line of symmetry. Oh, do me a favor, I didn't write it. LOS, please put that LOS there for line of symmetry. The line of symmetry is the time, because again, all of the X's are time. It's the time when the football is at its highest point. Okay. The line of symmetry will always be directly below the maximum. So let's see, line of symmetry is a time when football. By the way, these words only matter if you do part B. Part B, they give you a second problem, you work it all out, and they ask all the questions. Part A, you just get these 4 answers, the number pieces, and you're good. So these words that we're writing out are only if you decide, I'm going to do part B too. If you don't do part B, then this extra writing doesn't matter. Time when football is at highest point. And the maxima is the highest point. So what is the maxima or vertex? They mean the same thing. It's a maxima if it's going up. It's a minima if it's going down. But this word vertex automatically means the highest point. The lowest point, this is the highest point of the football. So if you're wondering when you're going to use this in real life, yes, when we're playing football. This is when you're going to use it in this. And let me pause though. Just to see if. So do this. Let's have you absolute value. Yeah, at this point, just type it in. A. What's going inside the absolute value bars? Thank you for thinking it. All right. Like. All right. And I did. Yeah, you saw. Yeah. And, in any case, type them all in one time. A little tip. The trickiest one is going to be the last one. So let me put in, so we have the absolute value, which is the letter B. For those of you who know what that picture looks like once you get it. Again, I think if you don't delete the former, I don't know if the slider makes all the pictures show up all at one time. There's the U, letter V. What's the third one? The third one is a radical. Again, no more than another 5 minutes with these. Let's do the radical. I think the only reason that some of you didn't do it last time was just ran out of time. The trickiest one to do is this last one. Oh, by the way, the radical looks like a ramp. It's like a, I don't know what you call that. It's like I don't know what you call it. A ramp or whatever. The last one is the trickiest one because unlike the others, where the K moves things up and down and the H moves things left and right, this last one is the ABC. And if anyone's nervous in here thinking like, there's no way I'm going to memorize all of these, they just put it on there. Your task is literally to do what you're doing right now. They will give a picture, and your task will be to manipulate using your sliders the picture. The only one that's tricky is this ABC. Once you type them all in, if you hit the bubble that eliminates the picture, move the A, B, and C around. It's weird. Yes, it's weird. So if you had to miss any of them, the ABC is the tricky